Okay, again, what equation, what system of equations put it this way, what is the corresponding system of equations? Well, you should see it. You know, this stands for 1x plus 0y equals 1/3. This stands for 0x plus 1y equals 5/3. Now 0y doesn't have to be written out, and 1x is just the same as x. That is, x equals 1/3, y equals 5/3. Now, this is the equation that's equivalent to this augmented matrix. Just call this an augmented matrix. The first equation was equivalent to the system that we analyzed previously. So that by going down through the rows of this system, treating them as we would equations, without worrying about x or y, just worrying about let's get a 1 here, then let's get a 0 here, then let's get a 1 here, and then let's get a 0 here. We did what was necessary to do that, and we came out with a system of a matrix that stands for this system. Of course, this system is the same as this. Okay? Because every matrix here, every augmented matrix corresponds to the system that we saw over here. And it should, because we did exactly the same operations with exactly the same goals as we had here. We wanted to get an x here by itself, so we would end up with x equals something. We wanted to get a 0 here because we don't want a y, we don't want an x in this equation that's going to end up y equals something. Okay? So we have to have a 1 here to get x equals. We want a 0 here because we want this one to read y equals. Now we want a 1 here instead of whatever we get at this stage, because we want to get y equals. And at this stage we have y equals. We have our y equals 5/3. And that's the same as the equation you get here, y equals 5/3. So we get a 1 here, we get a 0 here, we get a 1 here, and now we have our y equals 5/3. One more step. We need to get a 0 here to go with the 1 here, so we get an x equals without any y in the way. So we do whatever's necessary to make that happen. Okay? Now, I think I can, well, we're kind of losing some of our information here without going into too much detail. The things that we did to the equations are the same things we did to the rows. Here we say we multiply row 1 by -1/2. That's our first step. What do we do here? We replace equation 1 by -1/2 of equation 1. That's exactly the same thing as multiplying the row that represents equation 1 by -1/2. Then what do we do? To get a 0 here, we subtract the first row from the second and put the result here. Okay, so what did we do here? Well, we did equation 2, the second equation, minus the first equation. This equation here, minus this equation to get this. Identical operation. Here, we didn't have a 1 in front of y, so we multiplied this second equation by 2/3, so we get y equals. What do we do here? We multiply the second row by 2/3, getting something that stands for y equals. And it's y equals 5/3, just like this one is. Then we needed to get a 0 here, so this would read x equals. So we add a multiple of this row to this row. Turns out if we multiply this row by 1/2 and add it to this row and replace this one, this is what we get. It stands for x equals 1/3. And now our system stands for the same thing that we got here.